Hello everyone, this is my lab 4 with bar magnets, so let's get started. So the purpose of lab 4 is to understand how the magnetic field interacts with distance, and the key physics principles that we use in this lab are the magnetic dipole field, Biot-Savart law, magnetic field superposition, and vector components of magnetic field. And the system is the interacting magnet and the magnetometer that is found on an iPhone, and the surrounding is all other elements outside of the magnets, or the magnet and the magnetometer. And so the experiment set up here we have our iPhone that we are continuously moving along the ruler, and at the end of the ruler on the top side there is a magnet. So we continuously are moving our iPhone, or basically changing the R distance between the magnet and the iPhone, and seeing what the results are with the magnetic field. And so here are our experiment results. And then our calculated n, or slope, is negative 3.08, which aligns with our experimental hypothesis, which is that, or the real world physics, that the relationship between distance and magnetic field is negatively correlated. Here is our k value, and here is our mu value, which we calculated with these formulas right here. Moving on to our closed grip model, here I defined the variables as well as the formula for magnetic field, and then here I applied them with vectors to then get this visual right here. And then in conclusion, magnetic field and distance are negatively correlated, and the experiment supports the dipole approximation for a bar magnet and demonstrates the expected field distance, or the expected distance dependence on the magnetic field. And so some sources of error in this lab are the magnet not being a perfect dipole, Earth's magnetic interference, and the sensor position error, in that when we first have to orient the iPhone, it has to be perfectly perpendicular to the ruler and point towards a certain direction, and there could be some error in that our compass might be a little bit off. And so finally, what if the experiment did not compensate for the magnetic north? Then results would be skewed because the measured field would include Earth's magnetic field, leading to systematic error and distortion of the 1 over r to the power of 3 relationship. And what if two magnets were stuck together for the experiment? Then the magnetic field strength would increase due to a larger magnetic moment, but the distance dependence would still follow 1 over r to the power of 3, and the slope n would not change. And so thank you for listening to my lab.